What's up guys, welcome to part 2 of installing a LAMP stack on Arch Linux. So we have the Apache server up and running, but before we move on to installing PHP, MySQL, it's a great idea to check out the Apache configuration file. And one thing we'll do is change the location from which Apache serves web files. Currently Apache is serving files out of /serve http. And we can see our index.html file in that directory. Well, what if we didn't want our web files in serve http? We're going to change the location from where those web files are served. Let's start with the Apache configuration file. We can go to /etc, then we can cd into httpd. Now this absolutely depends on the flavor of Linux you are using. For example, if you are using Ubuntu server, it's very likely you will need to cd into Apache 2. Seeing as we're on Arch right now, we're going to cd into httpd. If we check out that directory, we can see that there is a configuration folder and also a modules folder. We'll refer to the modules folder shortly, but for now we're just going to cd into that conf directory. Inside this directory, the most important file for us right now is that httpd.conf. That's going to contain all, or at least most, of the configuration for our Apache server. So it is a file, it's not a folder, so we're going to vim into that. And let's check out the contents of the configuration file. My recommendation here is to just take the time to read through the entire file. And it might be worth looking up parts of the file that you don't understand. Notice the message here. Do not simply read the instructions in here without understanding what they do. They're only hints or reminders. If you're unsure, consult the online docs. You have been warned. Invariably, at some point, if you're creating some kind of web app, you're going to run into a problem with Apache. And this is going to be the difference between spending 5 or 10 hours crawling through different forums trying to figure out what's going wrong, with spending half an hour fixing an issue that you're already familiar with, or in some cases maybe just a few minutes. So invest the time now, invest an hour looking at this document. It's going to save you a lot of time when something invariably goes wrong with your Apache server or it's not behaving like you expect it to. Now we're going to look through a few important highlights of this document, but we're not going to consider everything. We're just going to consider the things that might be relevant for the initial configuration of the Apache server, but there's a lot more that we can do here as well. The first highlight here is the server root. It points to the directory where all of the Apache configuration, error, and log files are kept. In fact, this is the directory we're in right now. We could, if we wanted to, change the directory from which all the Apache configuration files are stored. The next highlight is the listen port. Apache by default is going to be listening on the same port as pretty much all web servers, which is port 80, but there's no reason why traffic has to be served over that port. If we wanted to, we could choose a different port to connect to via our web browser. For example, we could serve the website over port 3000. And in our browser, we would go to localhost. We'd use a colon to designate port, and then we choose port 3000 and we could connect that way. Then we reach a section of the configuration where we can load Apache modules. We can think about these as extensions to the way the base Apache package or web server works. We can see the syntax here, load module, followed by the location of the module file. And we can see in this case, the extension of these file names is .so. That's because these modules are what's known as dynamic shared objects. All we really need to know at this stage is that we can load a module using the load module syntax and specify the location of the .so file. And this is going to be looking in the modules folder by default. So you can see, for example, the location of that first module there is modules / then the file name. Remember, we saw the modules directory. It was in /etc httpd modules. Notice that some of these load module statements have a hash in front of them. This means that they've been commented out. they're not actually going to be looked at by the Apache server. But if we wanted to enable some of these modules that have been commented out, all we would need to do is remove that hash character at the beginning of the line. If we wanted to stop a module from loading, we could just add the hash character in front of some of the existing load module statements that we have here. Now you might be wondering what some of these Apache modules actually do. We'll consider a couple of them as we work through the document, but for now, let's keep moving. And let's take a look at this user HTTP and group HTTP setting. And you'll notice it's wrapped in a tag if module unixd_module. So let's start with that user and group designation, and the comment section helps us to understand what's going on. When we run the HTTP daemon, it doesn't necessarily run as root. In fact, it's a good practice for the HTTP daemon to automatically run as part of its own dedicated user and group. So HTTP service is launched, it's actually running as user HTTP and group HTTP. We could change the group it runs at, although there's really no need to change the setting in most cases. Now let's return to that if module unixd_module. This is essentially a conditional statement. So we're saying if the module unixd_module is being loaded, then make sure Apache is running as user HTTP and group HTTP. Now why is it important that unixd_module actually loads in this case? Now we're not necessarily expected to know what every single Apache module does, so it's just simply a case of Googling to find out what these modules do if you are interested. So to give you an example here, this unixd_module has the description, this directive tells the server to chroot to the specified directory. In other words, it needs this particular module in order to run Apache as the user HTTP or the group HTTP, because part of that process is using the change root command. So the reason why it's wrapped in this conditional if module unixd_module is because if we don't have that unixd_module enabled, then the following directives aren't going to work correctly. And we can confirm for ourselves that these are in fact being loaded. If we scroll back up to the load module, somewhere we're going to find that unixd_module being loaded. We can see line 164, load module unixd_module, and then we have the location of the file, which is called mod_unixd.so. Moving onwards, we have the server admin email. This is fairly self-explanatory. It says that this address appears on some server-generated pages, such as error documents. Users hit an error, they want to know who to email. Well, they're going to be directed to email the address that we specify here. Now we get to some of the really important stuff in terms of security, so you may want to configure these options before launching your server. These options are provided within a directory tag. So in this case, all of the options between these two directory tags apply to the directory /. In other words, the root directory. The comment above helps us to understand what's taking place here. It's saying deny access to the entirety of your server's file system. You must explicitly permit access to web content directories and other directory blocks below. So what we're doing here is saying by default, nothing can be accessed. But then we're going to explicitly allow access to specific directories. Now there's two directives here, or options. The first is AllowOverride. We'll come back to that shortly. The second, which is what's most relevant here, is require all denied. The server cannot access anything in those directories. So if I try to use my browser to access stuff in that / directory somehow, it's just not going to let me access any of those files. Those are secure. Now we'll need to explicitly allow access to files that are necessary for running our web app. In other words, those in the /serve HTTP directory, such as our index.html file. The browser needs to be able to access those. If it can't access those, the site's not going to work. Now, first of all, we're going to specify the document root. So this is the directory out of which you will serve your documents. Now, it just so happens that I don't normally serve web files from this directory. It's an Arch default. There's nothing wrong with it. There's no real reason why you'd need to change this. apart from if I'm logging on to a different Linux distro that's running a web app, I would prefer it that my web apps were always served from the same location. And that location, which we're going to change right now, is going to be /var www/html. So as we go through, we're going to be changing this configuration file. The directory, now you recognize the directory tags here. It means that any options that we pass after this tag, in between this tag and the closing directory tag, are going to apply to the directory, which we're going to change now to var www/html. So we're actually going to move our index.html file as well to that directory because that's where we want to serve web traffic from. Now we are still inside that tag currently, and we see that there are some options specified. These are fairly important as well. You may have noticed in the first part of the series when we tried to navigate to localhost at port 80, it gave us a listing of the directory. It couldn't find that index.html file because we hadn't put it in place, and we received a listing of all the files in that directory. It just so happened that there weren't any files in that directory. Now this is the indexes option. Supposing the web browser is pointed to a location on the server and it doesn't find the index.html file there, well, what does it do? Does it just display nothing? Or does it display the contents of that directory? Now, depending on what we're trying to do, we might want to display the contents of a directory, or that could be a big security leak. So if we absolutely don't want that behavior, we should delete the indexes option. FollowSymLinks refers to symbolic links. So let's say that inside my web files directory, I want to create a symbolic link to a folder that exists outside my document root of var www.html. Well, I can do that, and it's going to grant the browser access to a part of my system that's not explicitly being defined as part of this var www.html directory. Once again, that could be a really useful feature to the way Apache works, or it could be a huge security problem, because now our user is potentially being able to access files that exist outside of the directory from which we serve web files. Once again, if we want that kind of behavior, we can leave this option FollowSymLinks on. If we don't, then we really want to secure our server and remove this option and maybe the previous option. Moving down, we have AllowOverride. AllowOverride is a really important function of the way Apache works. And without configuring this correctly, you are going to run into some problems. This is one of those issues that could take a while to fix if you don't know what you're looking for and your web server is just not behaving in the way that you expect. So when we create our web files directory, we can use a .htaccess file to configure the requests that come into our web app. So we could receive a certain request, and rather than taking our user directly to a resource, we can actually send them to a different part of our web app. This is very important if, for example, you want to handle your own web routing. So we can, of course, let Apache take care of routing, where, for example, user just navigates directly to a directory or a file such as index.html. But in most cases, that's not how modern web apps work. The routing is not taken care of by the HTTP server. It's usually taken care of by a server-side or sometimes front-end language. So the way that it might look if we're running a PHP app on LampStack is that no matter what our user types into the URL bar, they always get forwarded to the index.php file, which then looks at the address they've typed into the URL bar and routes them to the appropriate resource. Now, in order for that to happen, the .htaccess file needs permission to take whatever the user's put into the URL bar and always forward them or change that request and always send them to the index.php file. That's called overriding. This .htaccess file is essentially overriding the default behavior of the Apache web server. But in order for that to work, we need to give permission for that to take place. And that's where this AllowOverride option comes into place. So we'll leave it as none for now, but if we want .htaccess to be able to modify requests coming into the app, we're going to have to change that to all. For now, we'll leave it as it is. We then have require all granted. So we're basically saying the web browser is allowed to access files that exist within that location specified by our directory tag. So in this case, it's var www.html. Now we'll have a look at this directory index option. Let's just read the comments. Sets the file that Apache will serve if a directory is requested. So if we just request the root directory of where our web files are located, Apache is going to look for that index.html file. We saw an example of that in the previous part of this LampStack series. Apache automatically loaded up that hello world in h1 tags, which was stored in the index.html file. And it knew that that was the default file it should have been looking for based on this directive here. Directory index is index.html. Now, in most cases, modern web apps don't serve raw HTML. They do eventually serve HTML, but they do that with some kind of preprocessor. For example, a PHP file. It's going to be run as PHP, and the end result of that is going to be HTML that is output. So we may not want to route our users directly to a HTML file in most cases. We may actually want to route them to index.php, for example, which runs a PHP script and then ultimately outputs HTML, which can be used by the browser. In such a case, we can change the default file that Apache is looking for just by changing this from index.html to index.php. Again, we'll leave that for a later part of this series. We're going to leave it as index.html for now. Notice also that that directive is wrapped in an if module, dir_module. So this module is required for that behavior where Apache looks for a default file when a request comes into the web app. We have this files.ht and then an asterisk, which is essentially a wildcard character. And what we're telling Apache here is that if a file begins with .ht, then we don't want it to be viewed or viewable by the browser. This is essentially just a security feature. There's no reason why the browser should be able to access the htaccess file directly. We don't want our users of our web app to be able to see how that file has been coded because it essentially contains Apache configuration. And that's for us as the admin. It's not really for the users. We have this error log. This is going to be very useful for when your app is not working. We can specify the directory where error output is saved. So we can see it's var log httpd error log. And we also have various levels of error messages. And we've got some possible values there: debug, info, notice, warn, error, critical, alert, emergency. The further we go along this list, the less output we're going to get from Apache in terms of errors. Whereas if we have it on debug mode, it's going to give us every single error it comes up with, no matter how trivial that error is. Whereas at the other end of the spectrum, which is emergency, it's really only going to be giving us errors if something very serious is going wrong with the web server. Now, this is a very general error log directory. Notice in the comments it says if you do not specify an error log directive within a virtual host container, error messages related to that virtual host will be logged here in the directory we specify. However, if we do specify a specific location within a virtual host container, then the errors are going to be logged to that specific location and not to the general location that we've defined here next to error log. Now, what is virtual host container or a virtual host tag? It basically allows us to run multiple websites on a single server. So we know that our web server is going to have an IP address, and that IP address is found, in the case of running a live web app, through DNS resolution. So after our user types in a web address, a DNS lookup is performed, and the web browser then knows which IP address to head to. The VirtualHosts tag allows us to run multiple websites from that single IP address. So we could have the domain names of several different sites ultimately resolving to the same IP address. The request comes into the web app. The address of the request is considered, so the domain name. And based on that domain name, based on the configuration in the VirtualHost container, Apache is going to know which file to return. So I could have www.example.com and example2.com running on the same server with the same IP address. When the DNS lookup is performed for those two domains, the same IP address is returned. So either way, that initial request is reaching the same web server. But then, based on the information in VirtualHosts, Apache says, well, what was requested here? Was it example.com or was it example2.com? Then it's going to serve the appropriate files based on the domain that was requested. So if I'm running example.com and I've padded out all of the details in a VirtualHost container and that web app runs into some errors, I can have my own folder for errors that pertain to example.com, and I can specify a different error folder for errors that pertain to example2.com. Now, we don't really care too much about virtual hosts in this case because we're essentially just hosting one site on the local host. So it's good to understand the virtual host option exists. It's going to be very important if you are serving multiple websites from a single web server, which is very commonly done. But right now we don't care too much about it, so we're just going to keep on moving. Something else that's very important here is towards the bottom of the configuration file, we're going to see all of these include statements. For example, include conf extra httpd default.conf. These are essentially extensions to this main http.conf file. The only reason they're here is just so we don't have a super long conf file. In fact, it's already fairly long. You can see we're over 500 lines at this stage. And you'll notice when you install Apache on other Linux distros, for example, if you install Apache on Ubuntu, the main configuration file is much shorter than this and actually just includes a bunch of include statements to various folders. It's actually, if we're realistic, probably easier to manage than even this configuration file, which is, I would say, on the long side. But the idea is we can branch this out to very short configuration files and simply include them all in a main parent configuration file. So that's what we're seeing here, including additional files that essentially belong as part of this main configuration. We're just placing them in different files so it's easier to manage. There are other important aspects to this document, which is why it might be worth going through this again from the beginning, reading through the entire document. For now, we're interested in seeing whether we can serve that index.html file out of a different directory. So we're actually going to write and quit our changes to the file here. And what we should be able to do now is go to cd var www. In fact, it may not exist at this stage, so let's see how far we can get. So we know the var directory exists, so we're going to make directory www. And we're going to have to use sudo for that. Sudo make the www. We can cd into that www directory, and then we can use sudo make the, we can specify html. Now if we cd into the html directory, now we can create a new index file. And once again, because we don't have the right permissions, we're going to have to use sudo for that. Let's have a look at our newly created file. We're going to vim into that. We're going to have to type something a bit different so we can see if our server has switched over. So we're just going to put another h1 tag. And we're going to say, hello alternate world. close the h1 tag. I'm going to write and quit to the file. Just make sure we've got everything okay with that. There we go. h1 tags, as you can see, something a little bit wrong with the syntax there. We have a trailing extra tag that we don't want. I'm just going to get rid of that. And everything should look good now with that file. Now, I suspect that's not going to work directly. Let's find out. As you can see, at the moment, it's still showing us our old Hello World file. So what is the reason for that? Certain changes that we make to the configuration in Apache are not going to take effect until we restart the server. So that's the next thing we're going to do right now. So we can use a command sudo systemctl restart httpd. And let's see if it changes over yet. And there we go, hello alternate world. So it's important to remember, if you make any changes to the configuration file, make sure you restart the Apache server first. Again, that could potentially kill hours of your life. You're making all of these changes to the configuration folder. You're trying to figure out why Apache is not responding to any of your changes. Have you got the wrong file? What's going on there? Just remember this step. You need to restart your Apache server before changes are going to take place. Now we can serve all of our web content out of that var www html, but this is just a preference. You can also just use the Arch default and serve out of serve http. There's nothing wrong with that. It doesn't really make a very big difference in the long run. Okay, so we've boosted our understanding of how the Apache configuration settings work. The next step is going to make sure that PHP works with the Apache server. That's what we're going to be doing in the next part of the series. Thanks very much for watching, guys.